afternoon and welcome to Sedimentology Masterclass, and today we're going to be looking at shore faces or coastal systems. Now there are two things that you need to bear in mind when you're thinking about coastal systems. First of all, sea level goes up and down through time. So you will find that sometimes sea level is much deeper and sometimes much shallower. So that has an influence on the way that the sediments behave. And that's caused by factors like the wobble of the earth, the distance from the sun, and other factors which all lead to changes in sea level of up to 200 meters. But these changes are fractal, so they may be very small changes in sea level on a yearly scale, but over tens of thousands of years, those small changes will build up and they can create really quite significant changes in relative sea level. The second thing you need to remember is that sediments tend to build out through time. So if you have a river coming to the coastline, it will start feeding out sand into the coastal system, and that sand will feed its way out from the coast. And this is what we're showing in this diagram over here. So we've got these nice shore face sands sitting here. So this will be right along close to your beach. Here's the river deposits coming in. And you can see at time one, at the bottom of our succession here, here's the shore face sitting back over on the left-hand side. But over time, it starts prograding and building out and creating probably a delta or a shore face system that feeds out into the sea. So there's the sea sitting up there. So you can see that if we take a slice through this section right here, at the base of the section we've got shellful mudstones and really quite distal sediments. And then as we go up through the succession at any one point, we go from muddy to sandier to a very sandy system at the top of our succession. And then what will happen after that is that the sea will flood back in again and you'll go back to a shellful system. So you'll end up with what's called a parasequence, which goes from mud up to sand and then begins again with the next mud as it floods over. So what does this look like sedimentologically? Well, let's have a look at this diagram here. So we start off at the bottom with our shellful mudstone sitting in here. Then we pass up into a distal lower shore face sediments. So this would be thin sands. These are called starve sands. So they'd be laterally discontinuous and rippled. And then passing up from there, we get into the zone here at this point where we pass up into stormed deposits. So what's happening is that you've got sands that are being reworked by storms, and the types of sedimentary structures that are formed are called hummocky cross stratification. So you've got these wavy sand beds sitting in here that we're going to see when we go up onto the outcrop. And finally you go up to where the waves dominate at the coastline, so very close to the beach, and here you'll see trough cross-bedded sandstones, and this is caused by dunes that are being washed along the coastline by longshore drift. And finally, at the top of your parasequence, so at your parasequence boundary, the sea will flood back up, the sea level will rise, relative sea level will rise. You'll end up with flooding over the top of these and another set of mudstone deposits, which will begin the cycle again. So you can end up with a whole series of these parasequences stacked one on top of the other. So what does it look like in our outcrop today? This is a sketch of our outcrop. You can see the whole section is around 53 meters in thickness. We start off with a coarsening upwards sequence here, the first little parasequence, all within the lower shore face. And then at this point here, about 15 meters up the succession, we flood over the top and we go back into a muddy succession. And then the second sequence here, the top 30 meters of the succession, goes from thin sands, thickening up until you have this beautiful shore face sequence of sandstones here, which is around 13 meters in thickness. And this is a proven reservoir in our area here in Western Canada. Okay. Let's go on and have a look at the outcrop.